You know how your phone can stitch together a perfect panorama? Or how some software can take a bunch of random tourist photos and build a stunning 3D model of, say, the Colosseum? Well, have you ever stopped to wonder how that actually works? It all boils down to one really fundamental question in computer vision. How in the world do computers learn to understand and align different images? Okay, let's dive right in. So, to get our heads around this, we're going to start with a classic computer vision puzzle. And it's one of those things that seems, super simple for us humans, but it's actually incredibly tricky for a machine to solve. All right, so take a look at these two photos. I mean, you and I, we know instantly, right? It's the same bell tower, just taken from a slightly different spot. Maybe the lighting's a little different. Our brains just get it. But you got to remember, a computer doesn't see a bell tower. It sees two giant grids of pixels. And to the computer, the color and brightness values in those grids are totally, completely different. And that right there, that's the core challenge. How do you teach a machine to look past all those different pixel values and figure out that, hey, despite all the differences, these two images are actually showing the exact same object? Well, the first idea that might pop into your head is brute force, right? Just try everything. Take one image and start shifting it around on top of the other one. Move it one pixel to the left, then again, then up, then down, then rotate it a tiny bit, then scale it. You'd be checking millions, maybe billions of possible alignments to find the best fit. It sounds simple, but let me tell you, from a computing perspective, it is an absolute nightmare.
Yeah, the lecture material we're drawing from for this explainer puts it perfectly, and I love this quote. This code should make you really unhappy. And it's so true. Trying to check every single possibility would take, well, basically forever. It's just not going to work. There has to be a smarter way, right?
And of course there is. The really elegant solution, the one that powers pretty much all of modern computer vision, is to stop trying to look at the entire picture. Instead, you just focus on the most interesting parts. So this is it. This is the key insight, the big aha moment. Instead of comparing millions and millions of pixels, what if the computer could just find, say, a few hundred really unique, interesting points in each image? Just landmarks. If it could do that, well, that changes the entire game. And in the world of computer vision, we call these special points features. The best way to think about it is like you're doing a jigsaw puzzle. You don't start by grabbing two random blue sky pieces, right? No way. You dump out the box and you immediately start looking for the corner pieces and the flat-edged border pieces. Features are the computer's corner pieces. They're unique, they're distinctive, and they're easy to spot again, even if the image gets rotated or resized or the lighting changes. And you can see it right here in action. The algorithm is really clever about this. It completely ignores the big, flat, boring parts of the image, like the plain walls or the empty sky. Why? Because they all look the same. Instead, it zeroes in on the spots with a lot of detail, a lot of change, like the sharp corners of the windows or the edges of the building's silhouette. These are the high-quality features it can actually trust. Okay, so the computer finds all these unique points. Great, but how does that actually help it match two different images? Well, the whole process builds on this idea, one step at a time. Basically, it all comes down to four main steps. 1. Find the features in both images. 2. Describe those features in a special way that makes them easy to recognize. 3. Try to match them up. And 4, and this part is absolutely crucial, filter out all the bad matches. Let's watch it happen. Okay, so here we've got two pictures of the same book cover. For step 1, a pretty basic algorithm scans the image. It's just looking for simple things like corners. And you can see it's doing a decent job. It's flagging the sharp corners in the text and the little details in the drawings. Not bad for a first pass. But just finding simple corners isn't quite enough, especially if the image is rotated or scaled. So for step 2, we bring in a more powerful algorithm to identify what we call keypoints. And what's so brilliant about this step is that it creates a unique digital fingerprint for the area around each key point. That fingerprint is the secret sauce. It's what lets the computer recognize that point again, even if the book is bigger or smaller or tilted in the other photo. All right, now for step 3, the matching. The computer takes every single key point from the first image and tries to find its best buddy in the second image. And the result? Well, you can see for yourself. It is a complete and total mess. It's just this chaotic web of lines going everywhere. A lot of these matches are obviously wrong, but that's actually okay. It's part of the process. And this is where the magic happens. Step 4,
a really clever filtering algorithm comes in and looks at this total mess. And it basically says, hang on a second. If these images are of the same thing, then all the correct matches should have a consistent geometric pattern. So it figures out what that main pattern is, and it just throws away every single match that doesn't fit. And bam, just like that, you're left with this beautiful, clean set of perfect connections. The two images are now perfectly aligned. It is so satisfying to watch.
So that's the core technique. It's an incredibly powerful idea. And believe me, it is not just for lining up pictures of book covers. This is where we get to see the real world payoff, the really cool stuff.
This whole four-step dance, finding, describing, matching, and then filtering features, it's the fundamental building block for a ton of amazing computer vision tech. This is why it matters so much. It's the secret ingredient behind stuff you probably use every single day.
Think about this. This is how 3D reconstruction works. You can have software take hundreds, even thousands of different tourist photos of a landmark, like the Colosseum. It finds matching features across all of them, and by comparing those matches, it can figure out exactly where each photo was taken from and then build an incredible, detailed 3D model of the entire structure. It's amazing.
And yep, this is exactly how your phone makes those awesome panoramas. When you pan your camera across a scene, your phone is working like crazy in the background. It's constantly finding and matching features between each little frame of video to figure out precisely how to bend, stretch, and stitch them all together into one massive, seamless photo. So in the end, it all comes back to that one simple but incredibly elegant idea: don't look at everything, just look for the interesting parts. And that kind of leaves us with a final thought to chew on, right? If a computer sees the world as a collection of these unique features, what are the features that our brains latch onto every single second to make sense of the world around us? What are our personal corner pieces? Something to think about.